All right, welcome everybody to the session on language acquisition and the role of syntax. I'll be the chair today, and we'll hear from 4 different presenters. So each presenter is allowed 20 minutes with 10 minutes of question afterwards. And I believe Blake will provide reminders, we'll cue speaker time from the chat. But at 20 minutes, I'll also notify you that your time to present is up. And for the question session, the conference guidelines are that, or best practices are that questions are for thoughtful questioning and drawing out new revelations, not for combat. We ask that you make sure the question is really a question and not a speech. We ask that you keep the question and answer short enough that others also have a turn, and I will limit follow-ups for that reason. And a good question would mention something positive about the talk and potentially a different way of looking at things. So without further ado, we'll first hear from Xiaomeng Ma with Virginia Valian and Martin Hodoro from Graduate Center at CUNY.
Okay, so hi everyone. So today I'm going to present Can Let Her Open It Explain Her Open It Errors. And at first, I'd like to thank my advisors, Virginia Valian and Martin Chodoro, for their help on this project. And so, yeah, first, let's look at children's pronoun case errors. So children are likely to make accusative for nominative errors. And some examples include me hurting my hair, where does him go, her wear that there, and so we can know where them are. So why do children make such errors? So many studies provided explanations for these errors, including the more linguistic explanations that assume children have some innate knowledge of pronoun case. For example, Schultz and Wexler proposed that errors are related to the maturation of agreement and tense checking, and also Rispoli proposed that errors are related to the maturation of morphological knowledge. And however, today we are only focused on a more input-based explanation, which assumes that children have little or no linguistic knowledge. So Tomasello proposed a hypothesis to this question, that children regularly hear things like her open it or help her open it. And so they may just imitatively learn the end part of the sentence, her open it. And so Karjavainen, Thigsten, and Lieven in 2009 paper provided some evidence of this interesting hypothesis. So they tested the data on 17 children with longitudinal recordings in childish corpora, and they found that children's me plus a verb errors, such as me go, are correlated with parents' me plus a verb sequences, such as let me go. And so if children verb errors by mistakenly imitating parents, then children should also make accusative plus verb errors with other pronouns, not just me. And also, children should not simultaneously produce correct accusative plus verb sequences, such as let me do it. And so for our study, we replicated Karjavainen et al. 2009's method to see if those two questions are true with more children's data. So in our methods, we used more children's data, including 46 children's longitudinal recordings in childish. And we also examined other accusative pronouns, including her, him, them, as well as me. So we use the same method to generate children's data. So first, we counted the correct accusative plus verb sequences, such as help her find it. We down me, her, him, and them. And also we counted the incorrect accusative plus verb sequences, such as them, wanted. And also we counted the correct nominative plus verb sequences, which provides as a baseline, and also the denominator for our proportion, such as I wanted. And then we calculated the percent of correct accusative plus verb, which is the number of correct accusative plus verb over the sum of accusative plus verb and nominative plus verb. And we also calculated the incorrect accusative plus verb sequences, which is the total number of incorrect accusative plus verb over the total pronoun plus verbs. And similarly, we generated parents data in the same way. So we counted all accusative plus verb sequences in parents data. And so those include the common accusative plus verb sequences like help her find it, as well as tag questions like help me, will you? And we also calculated the correct nominative plus verb sequences, such as I wanted. And then we calculate the percentage of accusative plus verb over total accusative and nominative plus verb sequences. So let's look at the data summary for all children's ACT plus V sequences. So first, not all children made accusative plus verb errors. So we see that apart from me plus verb, so remember we have 46 children in total, and me plus a verb is the most popular error, that 41 of children made errors on this particular sequences. And however, for him plus a verb, her plus a verb, and them plus a verb, about half of the children didn't make any errors on those. And also for plus V, we see that children use the accusative pronoun in the correct context way more often than the errors. For example, for me, children made 2,588 correct let me go, comparing to 934 me got it. And also the low proportion, the low percent of the act plus accusative plus verb sequences showed that generally children know that they should use a nominative pronoun before a verb, and they also predominantly use a nominative pronoun before a verb. And then we calculate the correlation. So first, we calculated the correlation of all 46 children's error with their parents' ACT plus V sequences. And so the only significant correlation is on her plus verb sequences. So we didn't replicate Kershaven et al. 2009's result that we didn't find a significant correlation between children's me go error and parents let me go sequences. And similarly, there is no significant correlation on him plus verb and them plus verb. And so further, so since we found that not all of the children made errors, so we further repeat the correlations with children who made more than one errors. And so again, so 34 children made more than one errors on me plus verb, 12 children made more than one errors on him plus verb, 21 children made more than one errors on her plus a verb, and 17 children made errors more than one errors on them plus a verb. And however, still there is no significant correlation between children's me go errors with parents let me go sequences. And also furthermore, if we are curious about what about children's errors and their own correct uses. And so we did the correlation between errors and correct uses of all 46 children. And also we only found the significant correlation on her plus a verb. We didn't find any correlation on me, him, and them. So children's me go is not correlated with their let me go production. And similarly, we did the correlation on children who made more than one errors, and there's still no significant correlation. And furthermore, so we also calculate the correlation between children's correct uses and parents' input. So so it's the relationship between children's let me go and parents let me go. And again, for all 46 children, there's no significant correlation. And also for the children who made more than one errors, there's no significant correlation either. So for most pronouns, children's errors are not correlated with children's correct uses or parents' input. And then we have another question. So if children made errors by imitating parents' input, then probably like the parents are different. So like some parents produce more act plus V sequences, so their children are kind of misled by those sequences. So we ask the question, so do parents of children with more errors produce more let accusative plus verb instances? And so we have the non-error group, so children made less than one error, and the error group, children made more than one errors. And so we can see that the mean percentage of act plus verb, accusative plus verb percent are not different for the error group and the non-error group. And also none of the t-test is significant. So parents' input is not different for children who make errors and for children who don't make errors. So in addition, we also find other evidence against input as the source for children's errors. Because apart from simple errors like me go to school or him wanted, children also make errors like can me have it, or when me fall in the swimming pool, or a train me got. And so when the accusative pronoun is not the first word in the sentence, or the accusative pronoun as a subject is not the first word in the sentence, it's very difficult, or there's literally no sequences in parents' input that they could imitate. So for children to make those errors, they must have some knowledge about subject, or they are really creative in their error making. So the summary of our results is that let her open it in parents' input cannot explain children's her open it errors. So first, there is no correlation between parents' accusative plus verb uses and children's accusative plus verb errors. And also there is no difference in parents' accusative plus verb uses between children who made errors and children who didn't make errors. And also children are really creative in their accusative plus verb errors that it's almost impossible to find the exact same sequences in their parents' input. And so since we kind of showed that if children, it's very difficult to say that children made errors because they imitate their parents. Then the next question naturally we want to ask is that, do children already know about case? So if children do not make pronoun case errors by simply imitating parents' input, perhaps they represent pronoun case correctly. So the test that we are doing is that, do parents' uses of accusative plus verb correlate? And if so, do children's? So we assume that parents, as adults, they already have a certain knowledge about accusative pronouns. So different accusative pronouns should correlate in a way. So first, we calculate the correlation among parents' correct uses of accusative plus verb sequences. And we find that most of the accusative plus verb sequences are highly correlated. So the only two pairs that are not correlated is me plus verb versus them plus verb, and him plus verb versus them plus verb. And then so have an adult take also like those should is correct as let me go. There's no significant correlation between any pairs of the pronoun. So control the use of accusatives such as and between her plus and no significant.
So it looks like we're having some connectivity issues. So we're gonna wait on finishing Xiaoming's presentation. Oh, there she is again.
I'm so sorry. When I was locked out.
Are you able to share your screen again now?
Okay. Yeah, I guess it's really, really bad. It was fine for all the other nights. It's just so which slide? This one? Okay, good. So unlike their parents' use, children's accusative pronouns are not correlated, suggesting that they lack an adult-like representation of accusative case. So the conclusions of this study include, first, children's pronoun case errors are not due to parents' input. And second, children lack an adult-like representation of the pronoun case system. And the implication is that children learn each accusative pronoun as an individual word. And that's the end of my talk. And any questions and comments? Yeah, let me also share the PDF link for the slides so that it's easier for you to go back to the slides if you have any questions. A sec, let me find the link.
Wonderful. So thank you so much, Xiaoming, for that presentation. If you have questions, attendees, you can't, it seems you can't just unmute yourself, but please put the word question or Q in the chat, and I will allow you to speak. It looks like we have 2 questions in the Q&A. So Diane Lilo Martin, would you like to ask your question aloud, or sorry, allow you.
Oh, yeah. So yeah, I can definitely repeat the argument of children do not have a case system. Yeah, I guess the connection was really bad. So the argument is that parents, they should have a representation of the case system, and so then. So we assume that parents will treat different accusative pronouns in a very similar way. And so that's why we first calculated the correlations among children's parents' correct uses of accusative pronouns. And we found that they are highly correlated. So which means that probably for parents, when they say me plus verb, her plus verb, him plus verb, them plus verb, like underlyingly, they know, okay, it's just accusative pronouns. It doesn't matter in a syntactical way. And so this could be an evidence for an adult-like representation of the accusative case system. And however, when we look at children's data, we don't find any significant correlation. So this is among correlation among children's correct use of accusative plus verb. So let me go. So it's like if children already have an accusative system, then like when they say let me go, they are also likely to say let her go, or let him go, or let them go. And however, there's no significant correlation among any of those pairs for the accusative pronouns. And so this is the correlation among children's incorrect uses of accusative plus verb. So me go. So it's like, yeah, if they make errors on me go, they're also likely to make errors on her go or him go if they know what is accusative pronoun. And however, we don't find any significant correlation except for him and her. And so him and her are only different. So those are like the only difference is the gender. And yeah, so those are the evidence we say that since children's accusative pronouns are not correlated, and then but parents' accusative pronouns are highly correlated, so it suggests that they don't have an adult-like representation of accusative case.
Okay, thank you very much.
Thank you.
Next, we can hear a question from Misha Becker.
Hi, can you hear me?
Yes, yes.
Okay. Yeah, so I just had a comment, which is that there are also kids, and Nina from the Childless database is one of them, who use my as a subject instead of me. So she'll say things like my fall down or whatever. And that it seems like that might be also an argument you could use against the idea that it comes from some form like let me go, because you can't say let my go. Or I don't know if the people whose work you were addressing discussed that example.
Yeah, so in Tomasello's work, he didn't address that example. So it's like the input-based theories are kind of only focused on the accusative for nominative errors. And probably they would say that the genitive for nominative errors are totally different from accusative for nominative errors. And so they didn't really discuss the genitive forms in their hypothesis. But yes, we do see a lot of genitive forms used as subject, and moreover, genitive forms also used as an accusative. So children would also say, genitive also used as nominative, like children would say, my want something something. Yes.
Right.
So
yeah. That's the example that I was trying to bring up. Yeah. Anyway, it's just, I guess, more support for what your basic claim.
Yeah. Thank you.
Thank you.
And a question from Jeffrey Litz, it looks like.
Hi. Great talk.
Thank you.
I'm wondering if you can go back to Diane's question. So as I understood it, you were measuring the frequency of the parent's use of the grammatical form across different contexts. Is that right?
So actually it's not frequency, it's the percent.
But the percent is, presumably the parents don't make any errors. So the correlation should be perfect, right?
Well, not really perfect, because like me, her, them, him are different in context. So with the corporate data, probably we don't have, so it's difficult to say that the correlation will be perfect in a way.
No, but what I don't understand, I'm just asking a much simpler question, which is when you asked whether the parents' use of the accusative forms were correlated with each other, with themselves, right? Just among the parents, what were you measuring?
I think I'm measuring, like, if parents say let her open it, then parents is also likely to say let him open it or let me open it.
Okay, good. So you're asking if they produce those kinds of small clauses, do they do it for all the forms in the paradigm?
Yes.
Right. Yes.
Okay, good. And so, thank you. So now, why? I'm just not sure why that correlation. Do they use the whole paradigm? Why we expect that to be evidence that people do or don't have the grammatical knowledge? That's the part I think I'm getting stuck on.
Yeah, it's an argument we're trying out, basically, to try to distinguish whether children actually have a paradigm. And the argument is, okay, if you've got a paradigm, you should be equally likely to use what you've got across all of the pronouns that you've got. And parents do that. Children don't do it. There could be a lot of reasons children don't do it. But it was one thing we could think of to try to get at the paradigmatic aspect of pronoun case.
I see. Thank you.
Thank you.
We're actually really happy to have questions about that, because we ourselves are wondering just how good of a measure is this? How far could you press this?
Yeah, I think it's really tricky because there's all kinds of reasons that people might or might not use all the forms in a paradigm.
Yeah.
Yeah.
Yeah, especially since children are primarily concerned about themselves.
Yeah, exactly.
Yeah. But Xiaomeng has other reasons actually for saying that. It's a different talk. But Xiaomeng, I don't know if you want to say anything about your model.
Yeah, so yeah, I guess I still have some time left. So so in this model, we are trying to explain, we are trying to see if parents' input can explain children's errors. And then so we found that it's not efficient to explain children's errors. However, so parents' input such as let me go is also very powerful in a way that we try to see if it can explain children's acquisition. So now so from this correlation, we could see that children obviously don't really have an adult-like representation. And however, they also use the correct pronouns very frequent. And so the question is that how did they learn a pronoun case in the first place? And so we have a very simple distributional, so we have a very simple hypothesis that children could learn the case from their different distributional cues. So for example, when we try a trigram distribution like let X go, and then obviously X is more likely to be accusative case comparing to nominative and genitive. And so in our other study, we elicited all the trigrams around the pronoun, and we train a neural network to see if those trigrams are good at classifying the pronouns in the middle. And we have over 98% of accuracy. We only train on 6 parents' data, and the largest training sample is about 24,000 tokens. And so which is a very, very good result given the small amount of data. And so yeah, so the other reason like we did this study is trying to see that so parents' input cannot explain their errors, and however parents' input could be powerful in explaining their acquisition.
Thank you so much. Let's give a round of applause to Xiaomeng.
Thank you.
Thank you for everybody who asked questions. We're next going to hear from Camelia Blotu from the University of Massachusetts at Amherst, and Tom Roper, also from UMass. And the talk is entitled Roll Up is Too Complex for Romanian 5-Year-Olds, Evidence from Recursive Adjectives.
Can you hear me now? Yes. Okay, great. Okay. So hello, everyone. I will be presenting about recursive adjectives and trying to show that roll-up is too complex for Romanian 5-year-olds. So the basic research question we start from is, how do Romanian children handle recursion and coordination of adjectives that specify the same dimension? And we bring experimental evidence from both comprehension and production, showing that Romanian 5-year-olds seem to fare better with simple coordination than with recursion, and they often interpret recursive adjectives as coordinated. So just a second. Okay, sorry. Okay. So recursion is considered core property of human language, and Roper 2011 distinguished between two types of recursion, direct recursion and indirect recursion. Direct recursion is considered a default representation in a child's grammar, allowing a category to generate itself. For instance, this would explain children's ease with coordination from early on. So things like, and it's raining on him and I drawed the rain. But it also appears as a first stage in language acquisition in several structures like compounds, T-purer, maker, so interpreted as T-purer and maker, possessives, Jane's father's bike as Jane's and father's bike, prepositional phrases, so the parrot next to the hamster, next to the bunnies, the parrot next to the hamster and next to the bunny, and even adjectives, as we will see. Indirect recursion, on the other hand, generates a category indirectly through another node, and the order is very important for interpretation. So the parrot next to the hamster next to the bunny. So the hamster next to the bunny has to be computed first. Indirect recursion is an adult-like stage, unlike direct recursion. Experimental studies seem to show that the default is coordination, therefore direct recursion. This is the interpretation even of indirectly recursive structures. However, the results differ sometimes with the type of indirect recursion and the age of children. I will just, because there is a lot to say about the experiment, I will just briefly go through this. But the point is that, for instance, for compounds, children interpret them in an adult-like fashion only after the age of 6, 7. With possessives, it seems that most 3- and 4-year-olds interpret a thing like Cookie Monster, sisters picture in a conjunctive manner. And with PP recursion, similar results have been observed. So there have been various experiments done, for instance, in English by Sevchenko, Roper, and Pearson, showing that children tend to reduce something like the lion by the zebra by the bear to coordinations like the lion by the zebra and by the bear. And there has also been an experiment in Romanian, Sevchenko and Avram 2018, showing that Romanian 5-year-olds perform more adult-like with recursive PPs than English children. And it has been argued that this is because in Romanian, there is an overt prepositional marker of which acts as a cue to recursion, making it easier for children to cope with recursive structures. And Blote 2019 further showed that accuracy rates with recursive PP modifiers are even higher, so 77.17%, when 5-year-olds are exposed in the same task to both recursive and coordinative structures. It is as if the contrast between recursion and coordination helps children be more adult-like. In terms of adjective recursion, there have been some experiments. So Mate in 1982 showed that more than 50% of the 3- and 4-year-olds tested gave a conjoint reading to the structure the second green ball in context, interpreting it as the second and the green ball rather than the second of the green balls. Brian 2006 showed that 4-year-olds interpret big black balls as big and black balls. And if we look at the childish corpus, we notice that the children start by using multiple adjectives in coordination, so things like I funny little boy, and only later use them recursively. So we have things like a little big trailer. So we are going to focus on adjectives. So adjectives pose a challenge for acquisition for a variety of reasons. One major problem with adjectives is the word-to-word mapping problem, because it is very hard for children to understand that the word they hear for the first time refers to a property of an object rather than the object itself, because properties always tag along their object. And there is also a whole object bias in acquisition, so that when children hear a word for the first time, they tend to think it's probably a noun. And this makes adjectives kind of hard to test experimentally. But we will not actually be dealing with that problem because we are dealing with older children, let's say, at this stage. Another problem is the fact that languages seem to differ in whether they refer to properties by means of adjectives or noun. Even within the same language, we can have things like red versus redness, beauty versus beautiful. Another issue is the placement of the adjectives. So if we think of just one adjective, we might think this is simple. We just put it before the noun or after. However, when multiple adjectives are involved, matters complicate. And it has been argued that post-nominal adjective languages display a mirror image ordering of adjectives in comparison to pre-nominal adjective languages. So various orders have been proposed for the kinds of adjectives that can occur in a sequence. So I'm just going to read one: quality, size, shape, color, and provenance. So for instance, a beautiful small orange French vase. So it has been argued that so one can account for such orders in a syntactic, semantic, or pragmatic fashion. However, there is no consensus on post-nominal adjective languages because it seems that some people claim that there is a mirror image, but others say that no, this is not the case. And so we cannot really talk about innate hierarchy at this point. The data from language acquisition just sort of, suggests that children that are like between the ages of 2 and 5 don't do so well with these hierarchies. And it is only later that they become proficient, they become adult-like in dealing with such orders. However, we are not going to focus on those kinds of orderings between multiple adjectives specifying different dimensions. We are going to focus now on multiple adjectives specifying the same dimension, like big and small. And in these particular structures, children have to assign a recursive interpretations to recursive adjectives. And this may be considered problematic given the children's tendency to reduce recursion to coordination. So Romance, we know, orders even recursive adjectives in the opposite order to English. This is important because if in the case of the multiple adjectives specifying different dimension, one can say there is no mirror effect because it has been said before. With recursive adjectives, it's really not like that. There is a clear mirror effect, so we have to account for it. Romanian is noun adjective, so we have florile mari, flowers the big. This would be the big flowers in English. And English multiple recursive adjectives appear in the opposite order in Romanian. So the small big flowers is flowers the big small. And various accounts have been proposed for this, according to Nevin's 2011. So one is the head movement account. So just saying the noun moves across the adjectives, but this does not account for a mirror effect. Another view is the adjunction of adjectives view. So basically we are just saying there is such a thing as right adjunction, and this relates to a parameter. And we have an adjunct parameter, and some languages are adjunct first, some languages are adjunct second. And the third view is the roll-up of N view by Cinque, arguing that what happens is that the noun, so English has the basic order and Romanian just derives this via this roll-up operation. So basically what happens is the noun moves through the specifier of the second adjective, and then afterwards it pipes the whole A2, so the whole A2P to the specifier of A1. So we have a series of movements actually. That are quite complex, one of them being an XP movement. So the one that out of the two accounts, the ones that capture the mirror effect are the adjunction and the roll-up of N view. But they have different predictions about how Romanian children should behave. On an adjunction perspective, we would expect Romanian children to sort of behave in the same way with respect to adjective recursion and PP recursion, because both are derived via adjunction. On a roll-up perspective, we would perhaps expect children to have more difficulties with adjectives because PP recursion in Romanian is in the same order as in English, so there is no roll-up. So it's much easier than adjectives, which would imply roll-up. What about coordination? We didn't say anything, but there are multiple analyses offered for coordination as well. But the main point about coordination is independently of what analysis we choose, there is a flat analysis and there is a hierarchical analysis, but all sort of are simpler than roll-up in the sense that they just merge things together. So this is important. It will become important in our discussion later on. In the current experiment, we wanted to see how children handle recursion of adjectives both in comprehension and production. And we focused on adjectives specifying the same dimension. We didn't want to test things like small red flowers because small red flowers could easily be interpreted as small and red flowers. And we were not interested in adjective ordering restrictions. We wanted to see recursion, how children interpret recursion. Why gradable adjectives? Because we know they are context sensitive, because there has been evidence in the literature, Siret, Kennedy, and Litz, and Ebeling and Gelman, for instance, have shown that children as young as 3 are able to differentiate among gradable adjectives with respect to the role of context in setting the standard of comparison. So based on this kind of evidence, we expect that children are able to shift the standard and to understand such structures. Based on previous findings, we would expect that children should interpret recursive adjectives as coordinative often, which would enforce the idea that indirect recursion involves more complex syntactic and semantic operation. And we would expect levels to matter for processing and production. So the more embeddings, the more difficult for children. And of course, we expect production to lag behind comprehension. There are also some language specific predictions. So we know that indirect
It looks like Adina is reconnecting.
She got cut off. I don't know if I could, I don't have the slides in front of me, so it's hard for me to continue for her. What can we do?
I think she may be leaving the room and returning again. That seemed to help for Xiaoming. So
Okay.
yeah, if she returns, I'll pause the time for the
I'll pass the time. How about if I pass the time?
I'll pause the time, I said, so that
Pause the time. I was gonna, okay, thank you. That's a better method. Much better. Nuts. You know, oh, here she is.
Sorry,
Yeah.
I was disconnected. I don't know what happened. I'm sorry. I will share again. I'm sorry. Yeah, I apologize for this. I really don't know what happened. Yeah.
I've paused your time, so you'll have 8 minutes remaining.
8 minutes remaining. Okay, thank you so much. Okay, so I'll be brief. So basically, just from the current slide, just a second. So children had to draw circles and squares around various objects and animals. And generally, they had to draw circles to identify recursive structures and square to identify coordinative structures, because we wanted to make the contrast visual as well in order to help children. There was a training session where children were familiarized with squares and circles, and they understood that they could draw circles and squares without them being close to each other. In the testing session, we used 4 sets of pictures, which we showed on an iPad. There were a set of 16 flowers that were big and small, a set of 16 giraffes that were tall and short, a set of 16 blades of grass that were long and short, and a set of 16 squirrels that were fat and thin. And children heard things like, look, these are the big flowers from 1 to 4, and these are the small flowers from 5 to 8. In comprehension, they had to draw circles and squares around sets. So they were told, among the small flowers, which are the ones from 7 and 8, some are smaller, and the 8, and some are bigger, 7. Can you draw a yellow circle around the big, small flowers? So that's 7. And in production, children had to name various sets. So we tested recursive structures that were with 2 adjectives, 3 adjectives, as well as in comprehension and production, and coordinative structures between 2 adjectives and 1 adjective and 2 adjectives, both in comprehension and production. And the results seem to show that unlike adults who are almost always at ceiling, children seem to fare better with simple coordination than with recursion, with production lagging behind comprehension. Only simple coordination between 2 adjectives, so big and small flowers, is easier for children, but not mixed coordination. So when you have big and small big flowers. This is because this coordination is actually more complex. It involves coordination between 1 adjective and 2 recursive adjectives. Importantly, while errors in coordination were rarely due to recursion, most errors in recursion comprehension were coordinative, 41.43%, followed by deleting or adding an adjective. So choosing the larger or the larger set or the subset. And in recursion production, errors were generally because of children's use of simpler forms. So only one adjective, for instance, or only two adjectives instead of three. So here you have some graphs. So you can see that comprehension of recursion is 35% with two adjectives. It is higher with three adjectives. This is unexpected. And we expected it not to be like that because we thought more levels of recursions should be more challenging, but the results are easily explainable if we think about the fact that in Romanian, just as in English, there are certain structures like big flowers or small flowers that have an intensifier reading. So they mean actually something like very small, very big. So in that particular situation, there is a competition within these intensifier readings, and children seem to pick quite a lot of those readings. And because of this, the results are not necessarily wrong, but they were not recursive in that sense. They are intensifier interpretations. If we leave those aside, so if we just eliminate those kinds of answers, we end up with a better rate of accuracy for comprehension with two different recursive adjectives, namely 66.25%. And there are many kinds of errors, but the most important ones are the coordination ones. So fat thin squirrels are thin and fat squirrels, and the larger and the subset ones. In production of recursion, you can see that children don't do very well. So you can see here what happens. And there were many errors, one adjective, and then also sometimes the reverse order of adjectives, and then sometimes just simple nouns or invented nouns even. So things like grass or angels. So sometimes they produce such things. With three adjectives, it's even worse. So there are very few correct adult-like answers with three adjectives. And they also give one adjectives answer, two adjectives answers, and sometimes coordination between adjectives. However, in the comprehension of coordination, things change. So here you see the proportion of accuracy between children and adults is quite similar. And children, even the errors that children produce are still coordination. It's just that they identify the sets wrong. And in comprehension of mixed coordination, however, the situation is not that good. They are not very accurate, but adults are not either. And they make a lot of errors, but they do give coordination answers. It's just that they have problems identifying the sets. And this is because one of the conjuncts is recursive. And in production of coordinations, things are better than with recursion. It's 57.5% with two adjectives. And most of the errors are still coordination, but they identify a different set. And with mixed coordination, it's quite terrible. But yeah. In any case, so we tried to do the statistical analysis, and the statistical analysis shows significant differences between adults and children, coordination and recursion, comprehension and production. The question would be, given the results that we have, could we say that there are any adult-like children, or could we say that all children actually, none of the children cope with recursion? Well, actually, while most of the children seem to be at the default stage, preferring coordination, there were 6 children out of 20 that were consistently adult-like in the comprehension of recursion. So more than half of the answers they gave were recursive. Interestingly, all the children who mastered recursion with 3 adjectives also mastered recursion with 2 adjectives. However, none of the children were adult-like in the production of recursion, in the sense that even if they gave some adult-like answers, they were not more than half of the answers. In contrast, 14 children were consistently adult-like with simple coordination. So there is an important asymmetry between how children deal with comprehension and with recursion and coordination. So it seems that although most 5-year-olds are still at a stage where coordination is the default, some have gone beyond that stage. So the account we will propose is to argue that direct recursion is the default, as it involves a simpler operation than indirect recursion. Semantic-wise, semantic coordination is also easier for children than semantic subordination, because it doesn't involve establishing a subset within a set. And we will argue that Romanian children do not do roll-up, as it is too complex, involving various XP movements. We argue that acquisition considers hierarchies of syntactic complexity. So roll-up is more difficult than XP movement, which is more difficult than X movement, which is more difficult than no movement or merge. And the lower the syntactic operations are in this complexity hierarchy, the easier it is for children to use them. So what children do is they basically prefer merge or head movement. And this explains why they prefer coordination in recursive context and their ease with coordination. In addition to this, we also compare adjective recursion to PP recursion. So I want to remind you that in Romanian, recursive PPs occur in the same order as in English, so there is no roll-up. So we have something like the parrot next to the hamster next to the bunny, and we have the same in Romanian, the same order in Romanian. And if we look at the results that I obtained in a previous experiment, we noticed that the rate of accuracy with children is 77.17%. So this is higher than with adjectives. And this suggests that 5-year-olds seem to do better with PP recursion than adjective recursion. And it is not only higher in terms of percentage, it is also higher in terms of the number of children that are consistently recursive in their answers. Because out of 30, more than 20 are consistent in the PP recursion case. So because of this, we argue that this gives one more argument in favor of the idea that roll-up sort of introduces a greater challenge for the acquisition path. So the experiment predicts the acquisition path with indirect category recursion via roll-up, providing a greater challenge than just indirect category recursion, which we have in the case of PP recursion. So this is it. Thank you so much. And we are willing to answer your questions. Yeah.
Thank you so much for that presentation. If you have a question, you can either write question in the chat, write your question in the chat, or write your question in the Q&A, and I'll enable speaking.
Okay.
Oh, so it looks like we have an anonymous question.
Yeah.
Maria, are you able to read that? Yeah.
Yeah, the 3 adjective to adjective pattern could also be explained prosodically, with prosodic grouping helping with the structure overall. Do you have any evidence that it's an intensifier reading effect and not a prosodic grouping effect? Well, actually, we sort of do, in the sense that when I was testing the children, they would often talk like apart from what they were supposed to say. And sometimes they would say, because it's the biggest one, or, you know, so those things were kind of clues that they were interpreting it that way. And it happened various times. So I tend to think it's because of this intensifier interpretation that it's like they want to choose the most typical member belonging to the small class, which would be the small class. Let's say the small flower. Yes.
Can I add a little bit?
Yes.
Yeah, so the prosody issue is obviously relevant, and we want to understand what it does. It's not an explanation. It is somehow part of the representation that enables children to recognize recursion, and we should come to understand it. I don't know that their prosody is like adult prosody, whether hearing it or producing it, but I don't think it's an alternative. It's an important additional ingredient, which in fact one might think would complicate matters as likely as to facilitate them. But it isn't an independent form of explanation, I think.
Yeah, there's one more question from, I don't know, someone.
Yeah.
Caroline Jane. Yeah.
Hi, thank you for that talk. That was fun. I was wondering if you could talk a little bit more about how you elicited the productions from the kids. So I got that you got to get them to tell you which of a pair they were talking about. And part of the reason I'm wondering is because if it were me doing this as a child, I can definitely imagine myself saying it's the big flowers or whatever, but I can't imagine myself saying it's the big small flowers or that kind. You can definitely tell me it's different in Romanian, obviously, but I was just wondering if you could talk a little bit more about that. Thanks.
Yeah. So basically, whenever we try to elicit some structure from children, we usually introduced it with a comparative, or we would say something like, so these are the big small flowers. If these are, or these are the big flowers. If these are the big flowers, how would we call these big flowers which are smaller than these?
Ooh, Lord.
You know, so we would we would say something like, how would we call these group of big flowers which are smaller than these? So and it was always in contrast with the other group that formed the set. Because of this, there were actually answers where children did produce things like big small or small big, and they were correct. Yeah, but they also produce things like big or small, as you said.
Yeah.
But
or like,
but
I also,
yeah.
Sorry, I just want, it seems like they might also say the left big, you know, or things
Yeah,
that work.
sometimes they do things like it.
Yeah.
Let me add a little bit. We've done a lot of this in English as well. And sometimes with nice direct contrast, like, okay, can you show me the small big flowers? Now show me the big small flowers. So they can actually see exactly, and there sometimes would mix them up, but it's amazing. You can get kids to really produce the small, big, small flowers.
That is
and
amazing.
pull it out. And so if you work at it, you find out the kids really can manage these things at surprisingly young ages.
Wow, thanks.
You're welcome. There is one more hand, I think. Keith.
Thank you very much. Can you hear me? Can you hear me okay?
Yes.
Okay, thank you very much. Yeah, I was wondering. Yeah, I was particularly drawn by what you said about roll up in Romanian, because speaking as a formal stenatician, I work in the Chomsky minimalist framework, and nowadays people believe that movement, internal merge is on a par with external merge, but in the earlier stuff, Chomsky, in the 80s and 90s, was arguing that movement is more complex than merge, and the movement should be preempted, which I think it ties in with Berwick's subset principle, and you would avoid movement unless you would really have to. And so what you said about roll up, or the avoidance of roll up, seems to support the earlier model rather than the current minimalist model of internal and external merge. I'm wondering whether you can build on this and see, just see how strong is the evidence that in first language acquisition that movement is preemptible.
Can I respond to that a little bit?
Yes,
please.
Do.
Chomsky's recent claims are that internal merge is easier than external merge, which is to say movement is kind of the easiest form, which is a nice radical point of view. But notice that in this account, there are really two levels of movement. You have to move twice. So some kind of complexity is produced. Whatever account you want to give, you have to account for that phenomenon in syntax for these Romance languages, but also there's this acquisition evidence of a difference between the prepositional phrases and the adjective recursion, and a difference also between Romanian and English. So, this is in the middle of the theory. These theories are all relevant. The challenge is to say, how do we take the acquisition data seriously and make the linguistic theory explain it? So far, the best way is to say roll up. Indeed, it is a form of movement. Movement may not be more difficult, but two movements is certainly a different phenomenon than one.
Yeah. And also what you move matters. So it's one thing if you move a head like a noun, and it's one thing if you move a whole adjectival phrase.
Whole phrase,
so,
XP movement. Yeah.
So moving an XP is somehow, I don't know, more difficult than moving just like the noun. So I think it's not only about how you move or like whatever you say about movement, but also what you move, like it's the complexity of what you move is important. And and I mean, it's a hypothesis at this point, of course, but on an adjunction, if we adopt an adjunction account, then we would expect children to somehow do better with them, like do as good with them as they did with PPs, and it's not the case. So this is why,
Okay, so I think that also ties in with people who work on formal parameters. People like Ian Roberts, has shown that XP phrasal movement is heavier, more complex than, X head movements, and you would prefer no movement to a movement. So a movement in that sort of early minimalist 90s account is more complex than merge. Yeah, but I was wondering how we can tie this in with the current model of internal and external merge. But you've given me a very informative answer. Thank you.
Thank you
so much.
And everybody who asked questions. We'll move on to our final talk of the session. We'll hear from Carolyn Jane Lutkin, Geraldine Legendre, and Jane Lutkin, all from Johns Hopkins University. And the talk is titled A Cross-Linguistic Comparison in Children's Interpretations of Complex Questions.
Excuse me, there are 4 talks in this session. Isn't that right?
I'm so sorry. Yes, we'll hear from the third talk. I'm sorry.
Okay.
That's An Nguyen. Are we not hearing from An Nguyen? Oh, there you are. Okay, wonderful. I didn't see you. Okay, so we'll now hear from An Nguyen and Geraldine Legendre from Johns Hopkins University on the acquisition of English WH in situ.
Okay, hi everyone. Thanks for coming to the talk. I'm Anne, and today I will present to you the work on the acquisitions of English WH in situ questions that we did at the Language Acquisition Lab at Johns Hopkins University. So upon hearing WH in situ in English, perhaps many people will first think of echo questions. An echo question is used to ask for clarifications or repetitions of a previous utterance, like the example shown here. However, there is another type of WH in situ questions that is frequently used in certain contexts, such as quiz shows, classroom setting, legal questioning, and also in child-directed speech. I call this kind of questions probe questions. And here is an example of probe questions taken from ChildDesk. So you can see that the dad in this example uses probe questions and fronted WH question interchangeably. So he asks a fronted questions first, and then when the child doesn't respond well, he restates the questions again using the in situ form. Moreover, his in situ question doesn't ask for repetitions. It is asking for new information, and it functions similarly to a genuine fronted questions. So this suggests that probe questions and fronted WH questions are rather similar. Otherwise, the dad wouldn't be able to use them in alternations like this. And our group is interested in this kind of in situ questions because it has not been discussed much in the language acquisition literature of English before. So WH in situ questions are typically overlooked in discussions of WH questions acquisitions because of an assumption that children only know in situ questions as echo questions. And echo questions are not like genuine type of questions, but this assumption is not true because like I show you here, there's another type of in situ questions and non-echo information seeking in situ questions. So to help you understand more about this kind of probe questions, here is a closer look at their characteristics. So compared to echo questions, probe question asks for new informations, while echo questions, like I said, ask for repetitions or clarifications. And so this further leads to some more pragmatic constraints. So echo question has a very strict context requirement. It can only occur as a reaction to a previous utterance, and it can never be the first question in discourse. It also has a very strong presupposition that the addressees of echo questions can answer the questions. So saying like, I don't know, would be infelicitous for an echo questions. Probe questions, on the other hand, doesn't have such a strong context constraint. So in certain contexts, it can be the first question in discourse, and the answer can be anything, basically, including I don't know. So both of them are in situ questions, but they differ in terms of prosody. So probe questions, so this one here, probe question is this one here. it has no stress on the WH word. It has a flat, a falling pitch, while echo questions on the other hand have heavy stress on the WH word and also a very strong rising pitch. So I will play an audio example of each type taken from Chidas. So try to pay attention to the WH word. Here is an example of probe questions.
And he's gonna go where?
Can you hear that well?
And he's gonna go where?
Sorry, I cannot see.
I could hear it.
Okay, yeah. And here is another example of echo questions.
We gotta do what? We gotta do what?
Yes. So you can see that there's like difference in prosody between the two type questions. So probe questions and echo questions are quite different. The only similarity seems to be their in situ survey structure. Now, probe questions and fronted information seeking questions both ask for new informations. And there's some slight pragmatic difference between them. So while fronted questions can be used in almost any context, probe questions mostly appear in certain contexts, such as quiz shows, classroom, child-directed speech. And the one characteristic that these contexts share is that the addresser typically is in a more authoritative role than the addressive. So think of like the relationship between teacher and student, or like parents and children. So probe questions and fronted questions have different survey structure. One is in situ and one involves movement, but then they have similar prosody. So like both have like a flat or falling pitch. So here is another example of probe questions.
And he's gonna go where? And he's gonna go where?
And fronted questions.
What are you counting? What are you counting?
So now we have known that children are exposed to both in situ questions and fronted questions as information seeking questions. We are interested in knowing whether they will learn these two types of questions in the same way. Different theories have made different predictions with regard to this problem. So frequency-based account may suggest that fronted questions are preferred by children as they appear at a significantly higher frequency than probe questions. But economy-based accounts may suggest that probe questions are preferred because they are structurally simpler, namely they don't involve any overt WH movement or auxiliary inversion. So to answer these questions, we launched an experiment with children between 3.5 and 5.5 who are still learning WH questions. The experiment consists of comprehensions and a production task. The comprehension task is to confirm the children understand probe questions, and the production task is to see which structure they will prefer to produce given an appropriate context. So 20 children participated in the study. Unfortunately, 3 got excluded. We also have 12 adults serving as a control group. So in the comprehension task, we present children with 12 in situ WH questions, and we want to test the claim commonly found in language acquisition that children only understand in situ questions as echo questions. So if you recall from like a previous slide, echo questions and probe questions are both in situ questions. So they can have the same word order, but they will be different prosodically, and they ask for different informations. So now we want to see if children will give the right type of answer, namely whether a repetition answer or a new information answer to the right type of questions. The setup is like this. So participants will be told that they are going to listen to a story along with a classmate. They will both hear the story from a storyteller, and then they see the story unfold on a screen. The storyteller role is played by the researcher, and there's another research assistant who uses a puppet to play the classmate role. And this puppet only talks to the participants and never talks to the storyteller. So here is an example trial in the experiment. Imagine that you are watching the story along with the classmate right here. So the story is about the two characters. In each trial, the two characters would pass by an event that is about to happen. There are always three possible choices. So in this example, the event is the man is going into one of the building, and the choices are the hospital, the apartment, and the bookshop. Note that there are two white buildings in the story. So the two characters in the story never get to see the outcome of the event. So they didn't know where the man actually went, but this information was shown on the screen to the participants. And later in the story, the character will talk about the event and wonder what had actually happened. At this point, the classmate character who has been watching the story along with the participants will make a vague statement. So basically narrowing the choices from 3 to 2, but not informative enough to identify the unique answer. So in this case, the classmate said that the man went to the white building, which was true, but there were two buildings, white buildings in the story. So so after that, the storyteller will ask the participant questions. It will be either a probe questions or an echo questions. A probe question asks for new information. So we expect the participants to tell us the information they saw on the screen, the hospital. Here we rely on the assumption that participants would obey Gresham's quantity maxims and prefer to be more informative and precise. On the other hand, an echo question suggests that the storyteller is interested in a repetition of what she just heard. Since the classmate would not talk to the storyteller, we would expect the participant to repeat what the classmate said earlier, even though it is kind of like an under-informative statement and not the best answer. So we coded the answer as target, non-target, or wrong answer. Target is when the answer matches with the question type. So new informations for probe questions or repetitions for an echo question. Non-target is when the answer is technically not wrong, but it is infelicitous. So a new information answer for echo questions or repetitions for probe questions. And finally, wrong answer just means that they say something like a bookstore or an apartment, which is like totally irrelevant to the story. So the results show that none of the child participants consistently produce only one type of answers to all questions throughout the experiment. So they correctly produce almost twice as many target answer to non-target answer, and this is above chance level. So even though they didn't do as well as adults, this suggests that they do notice that there were two types of questions used in the study, and they changed their answer to match with the questions. Now within each type of questions, children perform significantly better with probe questions than with echo questions, while adults perform equally well with both questions. So this could be due to a bias toward a more precise answer, or it could be that children by default interpret question as information seeking. And so in order for them to get the echo reading, they need to do some extra work like paying attention and interpreting the prosody. So that would result in a lower accuracy rate. So in general, this result suggests that children can make use of prosody to differentiate among the two types of institute questions, even though they may not be as sensitive to prosody as adults are. This is in line with a number of research studies on children's use of prosody. And this result also contradicts the assumptions commonly found in acquisitions that children only understand WH in situ questions as echo questions. Now let's turn to the production task. So participants were introduced to Bippo here. Bippo is an alien that came to learn about things on Earth. Now he's going back to his planet, but before he leaves, we want to make sure that he knows enough about the Earth. So the participants' task was to ask Bippo questions. The setup of this task was designed so that it matches with the context in which parents typically use prop questions. So in this setup, first of all, the participants sort of already know the answer to the question they are asking the alien. And secondly, they are in an authoritative role compared to the alien because they know more about English and Earth than the alien. And they can also decide whether the alien should return to his planet or not. So there were 12 trials with 2 practice trials to demonstrate to children how to do the task. In one trial task, we use an in-situ questions, and in another trial task, we use a fronted questions. This is to show them that both structure are acceptable and they can use whichever structure they prefer. So here is an example of a practice trial. We tell children something like this. Let's ask Bippo if he knows about the object on the table. I will show you how I do it. Hey Bippo, that is what on the table. Now it's your turn. In a real trial, we just tell them to ask people about certain objects or people in the picture and provide them with no example. So the result of this task is rather straightforward. Children almost always produce fronted questions. There was a strong preference for this type of questions, but it's worth to point out that their fronted questions were not perfect. They made several mistakes, so this suggests that they still have not yet mastered these constructions. To summarize, so far the experiment has shown that children can differentiate between the 2 types of in-situ questions. So they show an understanding of prop questions, but show no preference for prop questions in productions. And before going to discuss this result, I also want to present a quick summarizations of results from the literature in another language, French. So both English and French have in-situ and fronted information seeking questions in child-directed speech. And also the distributions of in-situ versus fronted questions in child-directed speech are similar in both languages. So around 16% as have been reported in other studies. Now, elicited studies in French yielded a similar result to our study. That is, children show a preference for fronted WH questions, and that is great. But if we look into the production rate, we see that there is a difference in the production rate. So French children don't produce a lot of in-situ questions compared to fronted ones, but they still produce some around like 15%, which is quite close to the input rate. English-speaking children, on the other hand, produce prop questions at a rate significantly smaller than the input rate. So any theories that we entertain should account for both the similar preference for the more complex fronted WH questions in the 2 languages, and also the difference in the production rates of WH in situ in French and in English. So now let's go back to the 2 hypotheses introduced at the beginning. We see that our study results do not support the economy-based account predictions as children show a preference for fronted WH questions. Now, frequency-based account predictions is more in line with our result. However, frequency alone is not sufficient. It can explain the same preference for fronted questions in English and French-speaking children, but it cannot explain the different production rate in the 2 populations. Because if frequency is the only factor, then the production rate of English-speaking and French-speaking children should be the same, given that the input frequency are approximately the same. So we hypothesize that the difference between production rate of English versus French-speaking children is due to the consistency of the usage and in the initial belief about the data. Our analysis suggests that English probe questions vary more across speakers in terms of prosody compared to French in situ questions. So the more consistency in French in situ may make it easier for children to learn this structure. Moreover, since French allows for more ways to ask the questions in general, both in WH questions and in yes/no questions, we hypothesize that the initial belief or like analysis of children about the data distribution also plays a role. From this, we propose an input filter hypothesis stating that when there are many variants of a grammatical system, grammatical items, so in this case, it's information seeking questions, learners are less likely to use a variant if it has low frequency, like in situ questions compared to fronted questions, or if the variant is used inconsistently and the learner starts with a belief that there is small or no variance in the data, like in the case of English in situ against French in situ. So these claims are in line with a number of previous studies in acquisitions. So in conclusions, our study shows that children are exposed to both fronted and in situ information seeking questions. And comprehension tasks suggest that they understand the information seeking use of probe questions, but they show a strong preference for fronted questions in productions. And this result is better accounted for by factors like frequency, consistency, and children's initial analysis of the language than by economy of movement. So thank you for listening, and I am happy to take any questions you have now.
Thank you so much, An. We can get questions either from the Q&A, or you can simply type question into the chat. You can also raise your hand and I'll allow you to speak.
Hi. I have a question. I'm sort of puzzled about the explanation of the difference between English and French children's use of WH and C2. So as you said in the talk, the pragmatics of WH and C2 are quite specific in English and quite different from the pragmatics of WH and C2 in French. And so I'm wondering why your explanation of why English-speaking children don't use WH and C2 is because the pragmatic conditions on WH and C2 in English are simply not met for children because they are not in a position of authority.
Yes. I'm aware of the difference in the pragmatic constraints in situ questions in the two languages. And so that is why we are looking at elicited results instead of just looking at spontaneous production of WH in situ questions. So my hypothesis is that because in our production task, we have set up a very specific context that that is like the context matches with how probe questions are typically used. If children actually are motivated to produce this type of questions, then in this context, they should be able to produce it. But we don't find any productions or any strong preference for probe questions, even in like this context specifically built for this probe questions.
Okay.
Hear from Virginia Valian.
I wondered if you might try priming the structure. Do you think if you primed it that you would be successful? Because I think it raises the question of whether the children actually have the representation versus are able to figure out how to decode it.
Yes. Like I said, we have 2 practice trials in the production task, and the practice trial is kind of more like a repetition task in which the researcher show them how they would ask the questions, and then they tell the children, now it's your turn. You can repeat what I just said, or you can form a questions by yourself. And interestingly, like even in cases when the researcher used an in situ questions to ask the alien questions, when we told the children it's their turn, they would still not repeat the in situ constructions. They would form a fronted WH questions on their own.
So what do you think that means about what kind of representation the children have? So do they understand even on your story that WH moves from one position to another position?
Well, because in the comprehension task, we show that children do understand prop questions. They were able to tell like this information seeking prop questions apart from the in situ echo questions. I do think that they have representations of this type of in situ questions in their grammar space. So they are not producing it because the structure is not available to them. So that's why I think that they are not producing it because of other reasons, like we have mentioned in the discussions.
I can't raise my hand. Can I ask a question?
Sure, yeah, we'll hear from you, Tom, and then Diane Lilo Martin.
Okay, thank you. I think it's a great experiment. It's nice to see progress on it. The original work by Takahashi did show that kids had echo questions, but didn't guarantee that it was only echo questions. I want to point out something sort of in line with what Jeff was suggesting. Namely, there is a real important difference between the in situ and the fronted elements. Namely, fronted elements don't have the presupposition of reality that the in situ one does. So if you say, where did John go? You can give the answer in French, you can give the answer nowhere. But if you said John went where, il va où, that presupposes that he did go somewhere, and you just have to answer where that is. So what I think one ought to do, the next step, is to do an experiment on that difference. I can tell you how to do it. It's pretty straightforward. But I think you haven't eliminated the possibility that really information-seeking questions are different when they're in situ and when they're preposed.
We agree with that. I think especially in French, there are a couple of studies that tackle on this. I think the tense used in the questions kind of suggest these presuppositions. So if we ask the questions in present tense or in future tense, perhaps you will see that like this presupposition disappears. And so why it's true that there is like a difference in presuppositions between in situ and fronted questions. I think like the content of the questions itself and the tense that we use in the questions can also affect this.
I would imagine
all those factors, then
let me
maybe
add
this.
It's not entirely clear that adults are using the full range of pragmatic constraints or absence thereof in child-directed speech per se. That remains to be demonstrated. So we cannot necessarily straightforwardly extrapolate from adult to adult use of WH in situ in French versus fronting. So it is a complex question, and of course it has to be tackled going way beyond the simple comparison that was made here today as a preliminary discussion, but it's a very complex issue. It's not simple at all.
Yeah. No, I was just encouraging that that's the next step to take, is to look at that presupposition difference. Yeah.
Yeah.
And we have about 30 seconds to hear from Diane Lilo Martin if you still would like to ask.
Hi, yeah, just a quick clarification, because I think I heard you say or imply that the frequency of the WH in situ in the input would be the same between French and English. But I didn't think that was true. So can you explain that, please?
Yeah, so like in our corpus analysis study, we found the rate of institute questions in English to be around 16%. And we did not directly did a corpus study on French, but all the studies, we have found reports in all the studies that did their analysis, and the rate was also to be around 16%.
Okay, and does that collapse across all the different types, like the probe questions and the quiz questions and the echo questions, and the sort of the way the French optional movement questions?
Yes, French allows for a lot of more variations than English. And so I think this is like, this is 16% in French would be, 16% of institute questions against a lot of more variations, while in English it's just like 16% of institute question against fronted questions. So the real distributions is slightly different, but like just counting on like the number of like the frequency, then it's quite the same number.
Thank you.
Thank you so much. And we'll hear our final talk of this session. We'll hear from Carolyn Jane Letkin, Geraldine Legenge, and Jane Letkin, all from Johns Hopkins University. And the talk is titled A Cross-Linguistic Comparison in Children's Interpretations of Complex Questions.
Oh.
Hi, thank you. Let me get to, can y'all can see my slides? Is that true? Yeah, okay, great. Let me get to the beginning. It's giving me a notification that I can share the slides. Great. All right, so I'm Jane Letkin. Thank you very much for sticking it out to the end here. I'm really excited to talk to you about some of the research that I've been doing. One of my major research questions is about the relationship between processing and grammar competence. So in psycholinguistics, we know that language proficiency requires both advanced processing and grammar competence, but the exact nature of the relationship between these two things is still requires a lot of research. And a kind of sub-question of this is just how much children know about their target grammar. What do they know about the grammar of the language that they are learning? And one way that we can investigate that is by looking at the mistakes that children make. We can use their errors as a kind of window into their knowledge about the grammar that they're learning. And one famous example of using an error as evidence is over-regularization. So if we hear a sentence such as, I goed to the zoo, we can surmise that that child probably knows the rule for making past tense in English, but has yet to learn the exceptional verbs for that otherwise regular rule. So while there's a kind of straightforward explanation for this type of error, we have other errors that are a little more complicated to explain. So another famous mistake that children will make is in response to questions like, how did the boy say what he caught? Children will sometimes respond with a fish. It's a famous finding by de Villiers and Roper that has been repeated many times. And the question that I have is what actually causes this error? Because there are a couple of interesting hypotheses to explain it. In the first place, this might be the result of an incorrect parameter setting, which would of course be relevant to the question of what children know about their target grammar. And the reason it might be indicative of an incorrect parameter setting is that it's possible children have temporarily adopted what's called a WH scope marking or WSM grammar. And what that is, scope marking is a technique for asking questions that is viable in languages like German. And what happens is instead of using a single WH phrase to ask a question like, who do you think she loves? In German, you use two WH phrases, one which appears medially and gives you the, I'm going to turn on my laser pointer, and indicates the content of the question, and a second WH phrase which marks the scope of that contentful WH phrase. So this tells us that Vane here, who, should be interpreted as having scope over both clauses. And the way that this might appear as an error in child English is if a child thinks they have WSM in their grammar, that they're learning a WSM grammar, and they come across a question like, how did the boy say what he caught? They might think, well, here's a medial WH phrase that might carry the content, and here's a WH phrase that might be marking scope, and interpret this question to mean, what did the boy say he caught? And respond with a fish. But that's not the only possible explanation for why these errors might occur. It is also possible that these are the result of immature processing mechanisms. And by that, I mean something like immature working memory, limited attention, or inhibitory control. It could be a variety of things that all make up processing. So what that really means is that kids might actually have a pretty good grasp of their target grammar by this age, but their immature processing mechanisms could interfere and cause them to kind of trip up. So let's think about the predictions that these two different hypotheses would make. In the first place, if this error is the result of an incorrect parameter setting, we would expect to find it in both production and comprehension. And that's because we would assume that a parameter setting would underlie both production and comprehension. But in previous work done in our lab, published at the beginning of last year, we compared children's production and comprehension and actually found that they weren't correlated, by which I mean a child that makes this error in comprehension is not necessarily the same child that makes a production error. So this in no way eliminates the possibility that this error is the result of an incorrect parameter setting, but it encouraged us to investigate the second hypothesis, which is that these are the result of immature processing. So if we consider the predictions that that hypothesis makes, it certainly predicts that we would expect a relationship between performance on the language task, so on our comprehension task, and their processing ability. But that's a very general kind of term, so we need a way to measure processing ability. And it turns out that we can use working memory as a proxy measure for processing ability, which has been used, it's been used in previous research, and there are plenty of theoretical reasons for doing it. So I want to emphasize, we're not positing that working memory is the actual cause of these errors. Instead, we're using a working memory score as a proxy measure, as an indicator of processing mechanisms more generally. So now we can reformulate this prediction to say, if this error is the result of immature processing, we would expect a relationship between performance on our language task and working memory scores, okay? And furthermore, there's another prediction that we would make, which is that we would expect similar errors to appear in both English and German-speaking children, because we would expect similar processing mechanisms to be at work, regardless of whether you're learning English or German. All right, so this is where I'm going to spend the rest of the talk today, all right, focusing on these predictions. So what I'm going to tell you about for this current study is a comprehension task and a working memory task, and we're going to compare the results from English and German-speaking children. So to begin with our English speakers, we ran 50 participants and excluded 18 who couldn't do our filler tasks, which means we were left with 32 kids whose data we analyzed, whose range in age was about 4.5 to about 6.5. And I would like to point out that we started this experiment at the beginning of 2020. And so we had 12 kids participate in person and 20 who did so virtually. I'm happy to talk about the implications of that in the question period, but I just wanted to point it out. The procedure was within subjects, so every kid did both tasks. And working memory was measured using a forward and a backward digit span task, which I will describe now. So we wanted to do both forward and backward digit span because forward digit span has been associated with comprehension in previous work, but a composite score, so forward digit span plus backward digit span, has actually been suggested to give a more accurate picture of processing abilities. So we did them both. I used the tasks from the Differential Ability Scales 2 book. It's a standardized task. And it's really very straightforward. You ask the kid to repeat a string of digits, either forward or backward. You start with a 2-digit string and proceed to 3 if they get it right, and 4 until they're no longer successful at the task. And then based on how well they do, they get an ability score, which is normally in the about 100 range, that indicates how far they got in the task. Now the comprehension task is a questions after stories task, pretty traditional. We had 6 target questions and 2 fillers. And what this means is we tell the kids a pretty simple story and then afterwards pose a question. The fillers were used to be sure the kids could actually do the task. The questions were all of the form, how did Steve tell Sherry what he was going to steal? So it's all how questions with a what medial relativizer there. They were balanced for prominence of events, by which I mean the telling event was as important in the story as the stealing event was. And we were also balanced for past and future tense. So half the questions were future tense in the embedded clause and half were past tense. So next you're going to see an example of one of my stories. So this is Detective Sherry here, who has solved many mysteries against this bad guy, Evil Steve, but she hasn't caught him yet. Now she's pretty sure that Evil Steve is going to try to steal the Queen's crown at the museum today. And if we go to Evil Steve's office, we see he is thinking of stealing the Queen's crown, but he knows that Sherry is clever and is going to expect that. So he's going to trick her. He's going to tell Sherry that he's going to steal the Queen's diamond ring. And to do that, he's going to use his special fancy TV machine. But when he tries to use his TV machine, it breaks. So Steve is reduced to writing a letter to Sherry to tell her about what he's going to steal. Sherry gets the letter and she opens it and reads, "Foolish Detective Sherry, I'm going to steal the Queen's diamond ring and you can't stop me. Ha ha ha, Evil Steve." Well, Sherry thinks she better protect the ring, so she goes to the Queen's palace, but when she gets there, the ring is right where it belongs. Sherry figures out she's been tricked. She goes to the museum where the crown is on display and catches Evil Steve red-handed, and justice prevails. Now, after a much more repetitive version of that story given to children, they would hear a pre-recorded question posed by this friendly cartoon, Hillary Hippo, and they would hear, how did Evil Steve tell Detective Sherry what he was going to steal? Now, it's an open-ended task, so kids could respond with anything they liked and frequently did, but there were 4 answers that I expected that they would give. First is the correct answer, that's the letter. Second was the TV machine, which is a distractor. So it indicates they understood to answer how the telling happened, but they got the answer wrong. The answer to watch for is the false object response. That's a WSM-like interpretation. So that would mean they said the ring in response to this, which indicates they've interpreted this what as if it had scope over both clauses, and the question were really, what did Steve tell Sherry he was going to steal? The ring. And finally, I thought it was possible they might just ignore the matrix clause and just respond to this second clause here and answer what he was going to steal, which would be the crown. So now I can feel some of you saying that's a very complicated story. There's no way kids could do that. So let's listen to one.
Okay, here's my question. How did Evil Steve tell Detective Sherry what he was gonna steal?
By writing her a message.
Awesome.
Very good.
All right, so just in case the audio wasn't perfect, she said by writing her a message, which is of course correct. So overall, I thought children did remarkably well, especially given the fact that it was an open-ended task and they could say anything. Over 50% were the correct response. The most common error was a WSM-like interpretation. So that's about 16% were those scope marking-like errors. We saw a few examples of the other error types, though not as many as I would have predicted. One response type that I did not expect was that kids would frequently say, it was a trick, he lied, he didn't tell her what he was going to steal, which of course actually is correct, he did lie. So I didn't predict that they would say that, but it is in fact adult-like. I never had an adult respond that way when doing controls, but the other adults have told me that that was how they would have answered. And then we had a few other response types, which were generally kids making up their own answers to how the telling happened. So I want to point out that we did find more correct responses and fewer scope marking-like interpretations than previous work. We replicated our own findings, which is perhaps not surprising, it's the same lab. But the important thing here is we're wondering whether or not their performance on this task is going to be correlated with their working memory. So that's really the novel finding that we're looking for. So in terms of the working memory results, all the kids were able to do the digit span tasks. On average, they were high, they did quite well, but we did see a range. So now we're looking at the relationship between working memory and adult-like comprehension. So what this graph is showing you on the y-axis is their composite working memory score. And on the x-axis is their adult-like comprehension. So that's the percentage of times that they gave the letter as a response to this question. And as you can see, we have a significant finding here that shows that the higher your working memory, the more likely you are to give me an adult-like response. And the lower your working memory, the less likely you are to give me an adult-like response. So that's already something significant, but let's remember that I'm really interested in errors. And while there's only one way to get the answer right here, there are many ways to get the answer wrong. And I'm interested in one of them, which is the scope marking-like interpretation. So let's turn to that relationship next. Now, when I looked for a relationship between the composite working memory scores, I found no significant relationship with scope marking-like errors. But you might remember that it was forward digit span that was previously associated with comprehension. So when I looked at just the forward digit span score, we did find a significant relationship with the WSM-like comprehension. So now what you're looking at is the forward digit span score on the y-axis and the WSM-like comprehension. So that's the ring-like response to this type of question. And as you can see, the higher your working memory, the less likely you are to make this particular error type. And the lower your working memory, the more likely you are to make this particular error. And I also want to point out that for this relationship, age was not actually a significant predictor. So your working memory was actually a more reliable predictor of how well you would, or how likely you were to make this error, which I found interesting. So to summarize the English findings, we found more correct responses and fewer scope marking-like interpretations than previous work, replicated our own findings, again, perhaps not surprising, but we found that working memory does predict adult-like performance and that forward digit span alone predicts scope marking-like comprehension. So that's a summary of our English findings, but remember, we're also interested in how English-speaking children and German-speaking children will compare on their performances. So with the help of a grant from the National Science Foundation, I was able to do this experiment in Germany as well. So we went to Germany, we had 38 adults participate as controls who all answered 100% correctly, so that's good. We had 48 German-speaking children participate. I excluded 20 for failure to complete the filler questions. Again, they were about age 4 to about age 6.5, average at 5.5. Now, I want to point out this actually leaves only 28 kids for analysis, which is 4 fewer than in English, but the data collection had to stop as a result of COVID, but all of these kids are in person. So that is a difference that should be taken into consideration. All the materials were exactly the same as those that I presented for English, but they were done in German. But this time it's a mixed design, and this is why. All the kids did the working memory task, but I divided the groups, or divided the kids into 2 groups for the comprehension task. And that's because I wanted to see how they would perform on an actual scope marking question. So that's a question like this, which actually means something like, what did Steve tell Sherry he would steal? And I also wanted to see how they would do on questions like the ones I posed to the English-speaking kids. So directly translated, how did Steve tell Sherry what he would steal? So we got 2 groups for the comprehension task in German, but otherwise everything about them is the same. This was all run at the University of Konstanz with the help of Professor Bettina Braun and 2 excellent RAs who were native speakers of German who I trained to run the experiment. Everything was transcribed and translated by a professional translator at Johns Hopkins, and the transcriptions and the coding, which was all done by me, were spot checked by native speakers. So again, just like English-speaking kids, the working memory scores were kind of what you'd expect, higher than average within the normal range. Their range was a little bit narrower than English speakers, which I also found interesting. So in response to scope marking questions, so that means what did Steve tell Sherry he would steal? Children gave adult-like responses over 80% of the time, which anecdotally is pretty much exactly what I found in my previous work when I asked English-speaking kids this question. So when there's one WH phrase, what did Steve tell Sherry he was going to steal? Kids do really well. But in response to questions that include that relativizer, so now the question is, how did Steve tell Sherry what he would steal? We got a correct answer to the how question about a little over half the time. The most common error was a scope marking-like interpretation, and we had a few of the other error types. And if that sounds familiar, it's because you've been paying attention and you also have relatively good working memory, because that's exactly what we found for the English-speaking kids. So now what you've got is a comparison between the English-speaking children on the left and the German-speaking children on the right. This is their average response numbers. Gray bars indicate the correct how response. So now all kids are answering this question, right? So the gray bars are correct responses. The green bars indicate WSM-like interpretations. And then we have the other error types represented in blue and orange. There's no significant difference between the languages on any response type. And for both groups, and for both groups, the correct responses occur significantly more frequently than any other response type. and the WSM-like interpretations occur more frequently than the other errors. So basically what we're looking at here indicates that the patterns of responses for both English and German-speaking children are incredibly similar when it comes to answering questions like this one. All right, now let's turn to the relationship between working memory and comprehension for the German-speaking kids. Just like English speakers, working memory did predict adult-like performance. But unlike English speakers, there's not a significant relationship between working memory and any particular error type. Now, I think this is because we needed more kids, but the groups end up being quite small once you divide them into two. And also, even amongst those small groups of kids, they're actually doing really well. So the number of errors there are to work into the relationship are quite small. So basically, I think we need more kids. Again, age was not a significant predictor of their performance. And finally, in a model investigating whether the language group predicted performance, we found no significant difference between the two groups. So overall, we've seen that English and German-speaking children make similar errors. The target language doesn't seem to predict performance. There is a relationship between working memory and correct adult-like responses for both groups. And in English, there's a relationship between forward digit span and scope marking interpretations. So all of these things support the hypothesis that these errors are the result of immature processing mechanisms, but we've got to at least speculate on how, right? So what exactly is going on? So let's think a little bit about the processing involved in comprehension. We assume that processing is incremental. You hear one word at a time. As you hear each word, you have to form a relationship between that word and the words that came before it and the words that will come after it. So it's going to look something like this when we're working with our question. We hear our question word how, we have to recognize it as a WH phrase that needs a verb to describe and a gap to go in. We go along listening to our question, we come to the verb tell, which we have to recognize as ditransitive, and that it might be the verb our question word is referring to. As we hear the rest of our question, we come to another WH phrase that needs another gap to fill. And we have to remember that this isn't the main WH phrase. We have to maintain how as the primary WH phrase. And when we get to the end of the question, we have to recognize, oh, that what's acting as a kind of relativizer and how is the question that I should answer. So there's a lot happening here. And at the very minimum, we've got two WH phrases. And what I think is going on is that maybe it's children with better working memory who are better able to maintain that initial WH phrase as the one that they should respond to. I also think it's very possible that it's actually lower inhibitory control. That means kids who are unable to kind of keep what from interfering with that how are giving me these wrong answer types. Now, previous work has definitely talked about inhibitory control in production. Jeff Litz has done some work with that and other things. So this is my future work, basically, and I'm happy to hear other people's ideas about it. So generally, our conclusions are that our findings suggest no difference in performance between the two language groups, which means that the difference in what's licensed by the target grammar doesn't necessarily affect the child's ability to perform on this task. There is a relationship between working memory and correct responses for both language groups. And this supports the hypothesis that these errors are the result of immature processing mechanisms, which are affecting both English and German-speaking children in the same way. Thank you very much, and I'm happy to take your questions.
Thank you so much for your presentation. We have 7-ish minutes for questions. If you have a question, please write in the chat that you have a question, post it in the Q&A box, or you can simply raise your hand. And since we have a little less time left, I might prioritize questions from people who haven't asked yet. But it's not an issue yet because no one is asking a question yet. All right, we'll hear from Virginia Valian.
Hi, such interesting work. Thank you very much. And it was also just a pleasure to listen to you and the way you developed your story.
Thank you.
I have a thought about working memory based on some work that we're doing now in my lab, where nonverbal working memory with children is not operating in exactly the same way that verbal working memory is acting. And so I wonder if you've thought about that at all. I think there are differences there, and that, as it were, pure working memory isn't actually what's driving it. It's more how you remember verbal material.
Yeah. I definitely think that's relevant. I did decide to go with this task because I read several papers that had done verbal and nonverbal working memory, and they ended up trending together. So I decided this was safe. I'm interested in what your lab has found. I definitely think these measures are really coarse, right? So, you know, asking kids to do a digit span task is really, I don't think, you know, the same process as asking them to maintain a WH phrase, you know. So yeah, definitely interested in what you have to offer, and I recognize that that's a big question that's left. Yeah.
Thanks.
Yeah.
And it looks like we have a question from Tom Roper.
Oh. Should I read it, Tom?
Do it. Can you hear me now?
Yes.
Yeah.
Yes.
I love to see further work on this, and I think I loved actually the experiment itself was different and new. I have a number of questions though. First of all, there's so much other work in German on these questions. I was very surprised not to see you citing it. Petra Schultz showed kids copying, I guess the last BU. Jürgen Weissenborn has a bunch. There's work in Dutch that's almost exactly parallel. So I feel like there's a lot of work out there that needs to be looked at. Now in the German work, children do a lot more copying than English kids do. This is copying. And so, you know, the two WH cases are like, have been reported before by McDaniel, who was in this group. So that's a different construction, and we have to pay attention to it.
Yeah.
I also think the working memory thing is really questionable. I don't know what it is, but if you do a digit span backwards, you have to reverse the order of the digit spans. That's like doing a transformation. So maybe the working memory is being modeled on the language and not the other way around. It's such a mysterious operation to do working memory. So I think treating it like a given understood phenomenon is not the right approach. And you were saying the same thing yourself. You were sort of saying, well, this kind of memory phenomenon is pretty obscure. So that's my feeling about it. All the work together still is still very compatible with the idea that this is a parametric option that languages have.
Oh yeah, I actually think it's very possible that I actually think that there's probably is some parameter work going on younger than with the kids that I'm working with. But the errors that these kids are making, I think, are the result of a processing thing. But I agree with you. None of the work that I've done has eliminated the possibility that there's parametric acquisition happening.
Yeah, that's right. But then the processing phenomenon, that's kind of something that supports the grammar, not that interferes with it. That's the way I would look at it. So if you can make something easier to process, of course, that's going to be a help. It doesn't necessarily say that the grammar isn't there at all, or yeah, that's what I'd say.
I see. I think what you're saying. Yeah. So yeah, definitely. If you have better processing, then that is a support to your good grammar. That's what you mean?
Essentially, yeah.
Yeah. Yeah. But if you have bad processing, then or less mature processing, then I think that can wind up being a handicap, right?
Well, and it could be. If I have long words, if I did the whole thing with big long words, that would interfere with things too, right? You can almost anything you can imagine would do some make it, which encyclopedia do you most prefer? Well, kids are going to stumble over encyclopedia. It's a big word. Every aspect of what makes life complicated is gonna affect these things.
That's true. Absolutely. Yeah. Thanks.
Looks like we're almost out of time, but we had one more comment in the Q&A, and I think it was a suggestion for perhaps the work that was referenced in the comments last time.
Okay.
So we have time for one very quick last final question. In that case, thank you to all the presenters and to the organizers and the question askers for a really wonderful session.
Thank you.